Hello everyone, welcome to my channel. In this video, we will learn about the backward traversal method uh, in the multi-stage graphs. So we are going to solve this multi-stage graphs in the backward way, starting from the destination node to the source node. So here we are applying the concept of dynamic programming approach. So in the dynamic programming approach, we are solving the problem level-wise in the given graph. So this is the formula for the backward traversal method. So b cost of I comma j equals to minimum of b cost of I minus 1 comma l plus c of l comma j. So normally in forward traversal method we start from the node 1 then to the nodes in the stage 2 and then to the nodes in the stage 3, nodes in stage 4 and finally to the destination node. But in backward traversal method we start from the destination node and then we will go backward to the source, towards the source. So first we will write the we will apply how do we form this formula. So b cost of, so first we need to find the destination node here at the stage 5 comma 9. So b cost of 5 comma 9, that equals to minimum of b cost of, so what is the I value here? 5 minus 1, that is 4 comma l value is the next stage value, so 4 comma 7 plus c of 7 comma 9. That means backward cost of this node 9 in the stage 5, that equals to minimum of b cost of 4 comma 7. So then the value here is node 7 at the stage 4 plus c of 7 comma 9. So the path from 7 to 9. Okay. So what are the nodes connected to node 9 here? 7 and 8. So we have find out the formula for 7 here, right? So next we need to find this b cost for 8 also. So b cost of 4 comma 8. Okay, so node 8 at the stage 4 plus c of 8 to 9, 8 comma 9, right? So this is the b cost at the stage 5. So now we will see the stage 4. So next we will find the b cost of stage 4 comma 7. So stage and node value, that equals to minimum of b cost of, so what are the values connected to node 7 here? 4 and 5, right? 4, 5 and 6. So these are the three nodes connected to node 7 here. So first we will find the b cost of 3 comma 4, that is so node 4 at stage 3, so 3 comma 4 plus c of 4 to 7, 4 comma 7, right? Comma, so what are the next two nodes connected to 7 here? 5. Okay, b cost of 3 comma 5, so 3 comma 5 plus c of 5 to 7, 5 comma 7, comma, so what is the next node connected to 7 here? 6. So we are going backward, right? B cost of, so 3 comma 6, 3 comma 6 plus c of 6 to 7, 6 to 7. Okay, so this is the b cost of 4 comma 7. Okay, 4 comma 7. So next we will find out the b cost of 4 comma 8. So what are the neighboring nodes of the 4 comma 8? The node 8 at stage 4. So 8 is connected to 3 nodes, 4, 5 and 6. Okay, minimum of b cost of 3 comma 4. Okay, so 8 is connected to 4 at stage 3 and 5 at stage 3 and 6 at stage 3, right? Plus c of, so 4 to 8, 4 comma 8, comma b cost of So next node is 5, right? So the next connected node is 5. B cost of 3 comma 5 plus C of 5 to 8. 5 comma 8. So the next node connected to 8 is 6. So B cost of 3 comma 6. So 3 comma 6 plus C of 6 to 8. 6 comma 8. So in this manner we will write the backward cost of the each node at every stage. So next, so we have find out the 4 and 5, right? Next we will move, so next one step back, that is stage 3. Stage 3. So stage 3 we have 3 nodes 4, 5, 6 which are connected to 2 nodes. Okay, node 4 is connected to 2, 3. Okay, so now we will find out the cost, B cost here. B cost of 3 comma 4. So 3 comma 4, B cost of 3 to 4 equals to, so backward cost of 2 comma 2 plus C of 2 comma 4, right? So C of 2 comma 2 and C of 2 to 4. So minimum of backward cost of 2 comma 2 plus cost C of 2 comma 4 comma, so what is the backward cost of a next value here? So 3 comma 4, right? Next value is 3 to so the node, so next value is connected to 4 is 3. So BC of 2 comma 3 plus C of 3 comma 4. Okay, so this is the backward cost of 3 comma 4. So in the same manner we are going to write down the backward cost of 3 to 5. So right, so in the stage 3 we have seen the value of 4, now 5. So 5 is connected to 3 and only 3, right? 5 is connected only to 3. So backward cost of 3 comma 5. That is equals to minimum of backward cost of, so 5 is connected to 3, right, at a stage 2. So BC of 2 comma 3 plus C of 3 comma 5. Next, so we need to find out the backward cost of the node 6 in the stage 3. Okay, so backward cost of 3 comma 6, backward cost of 3 comma 6 equals to, so what is the backward cost of 3 comma 6? So here 6 is connected to node 3 only, right? 6 is connected to node 3. So minimum of backward cost of, so what are the nodes connected to 6 here? 2 and 3, right? So 2 comma 2, so backward cost of 2 comma 2 plus C of 3 to 6. So 2 to 6, right? So C of 2 comma 6 comma backward cost of, so what is the value here? 2 comma 3. So 2 and 3, 2 comma 3 plus C of 3 to 6. C of 3 to 6. Okay, so in this manner we have find out the values at the stage 3. So now we will go to stage 2. So nodes connected in the stage 2 are 2 and 3 to 1. So stage 2. So backward cost of 2 comma 2. So node 2 at a stage 2 equals to minimum of backward cost of, so 2 is connected to which node? So 2 is connected to 1, node 1, right? So 1 comma 1, so BC of 1 comma 1 plus C of cost of 1 to 2, 1 to 2 comma, so only this one, right? Okay, so next, so what is the backward cost of 3, node 3 at a stage 2? So backward cost of 2 comma 3 equals to minimum of backward cost of, so what is the backward cost here? 1 comma 1 plus 1 2 3, 1 comma 1 plus C of 1 2 3. Okay, so this is the backward cost. So now, so what is the value at stage 1 here? 1. So cost of 1 comma 1 is 0. So we know that cost of backward cost of 1 comma 1 equals to 0. Okay, so now we will substitute this one here in. So backward cost of 1 comma 1 is 0, here also 0, and C of 1 comma 2. So 1 to 2 is 5 and 1 to 3 is 2. So 5 and 1 to 3 is 2. Okay, so may B cost of 2 comma 3 equals to 2 and 0 plus 5 is 5. So 5. Okay, 5 and 2. So next one. So we are going to substitute the stage 2 values in stage 3. So what are the stage 2 values here? 2 comma 2. B cost of 2 comma 2 is 5. 2 comma 3 is 2. So 2 comma 3 is 2. So now we will find the values here. C of 3 comma 5, 2 comma 6 and 3 comma 6. So C of 3 comma 5. So C of 3 to 5 is 5, and C of 2 to 6. So 2 to 6 is 3, and C of 3 comma 6, 3 to 6 is 8. So we need to find the minimum here, right? So that equals to minimum of 8 comma 10 equals to 8. Similar way here, B cost of 3 comma 5 is 7. Okay, so next again we are going to substitute these values. Okay, we have 3 comma 4 here, right? So B cost of 2 comma 2 is 5, and C of 2 comma 4, 2 to 3 is 2. So C of 2 comma 4 and 3 comma 4, 2 to 4 is 3, and 3 to 4 is 6. That means minimum of 8 comma 8 is equals to 8 only, right? So now we are going to substitute the stage 3 values to stage 2. Okay, so what is the B cost of 3 comma 4 value? 8, 3 comma 5 is 7 and 8. 7, 8. So here also 8, 7, 8. Now what is the cost of 4 to 7? So 4 to 7 is 1, and 5 to 7. So what is the value of 5 to 7 is 6, and C of 6 to 7 is 6. So that equals to minimum of 9 comma 6 plus 7, 13 comma 8 plus 6, 14. That equals to 9. So here also we'll find the value. C of 4 to 8. 4 to 8 is 4. Similarly 5 to 8. So 5 to 8 is 2, and 6 to 8. So 6 to 8 is 2. Okay, so minimum of 8 plus 4 is 12, and 9, 10. That is 9. Minimum value is 9 here. Similarly, we will solve this one also. So minimum of B cost of 4 comma 7. Okay, 4 comma 7 and 4 comma 8 is, so what is the values here? 4 comma 7 is 9, and 4 comma 8 is also 9. So C of 7 comma 9 and 8 comma 9. So C of 7 to 9. 7 to 9 is 7, and 8 to 9 is 3. So 9 plus 7 is 16. So minimum of 16 comma 9 plus 3, 12. So it is 12. So finally the value from source to destination is 12, which is same as it is in the forward traversal method. So the minimum cost is 12 also in the forward traversal method. The same thing here repeated. Okay, 12. Okay, so in the similar manner, how we find out the path from source to destination, in the same manner we can find the path from destination to source here also. Okay, So like I'm going to say here, so 12, so the minimum one is 12, right? That is 4 to 8. Okay, so first we will select the path from 4 to 8 and then 8 to 9. Okay, so in this manner we will go backward here, one step backward, similar to the forward traversal method. So this is all about how do we apply the backward traversal method for multi-stage graphs. Thanks for watching my video.